So today I'm going to go over some supply chain attacks specific to Python when using pip. This is kind of a very nuanced or specialized kind of an attack, but it's kind of an old kind of a technique in a lot of ways. So a little bit about me. My name is John Pope. I'm the other Pope, or one of the other Popes. I work at Utah State University as a programmer analyst, and I'm an owner of a software development company called PopeTech, not an AV company. And I've been participating with SAINTCON since about 2015, when I got brought into AV with my brother James. I live up in Cache Valley, participate in various user groups and communities up there, favorite being DC435, and also help with usually more AV with B-sides. But I'm a web developer by trade. I've been doing web development for about 12 years, and that's who I am. So as I mentioned, this is kind of an old kind of a technique. If you're familiar with drive-by like downloads, that kind of stuff in the browser, it's kind of the same thing, but with package managers. So old things are new again. I came across the first form of this attack specific to development back in 2008. There's been various iterations on this. So learning about what tools you're using and what some of the compromise or ways that you can get attacked through your just normal workflows has a pretty long and lasting shelf life. The first thing we're going to focus on here is a little bit about what we're talking about. So there was an official project that was kind of a research project around Python and pip specifically. It was called Pydo squatting, and it's basically they went and published a bunch of standard packages in Python on the public index. Normally those packages are included in the runtime itself, but a lot of developers might still try to install them from the package index. So they went and published those packages on the index to kind of see how big of a problem this might be. And in the course of about 2 weeks while they were collecting stats, there were over 20,000 downloads over their packages, some 17 packages that they put up. So it kind of just illustrates this happens, this is a real thing. People don't realize they have things, or they misspell things, or they are tricked into putting in the wrong thing, and you'll get code running on your system. So earlier this year, there was a popular bug bounty that this gentleman wrote up about on Medium, Alex Persson. It was dependency confusion was the term that he used. And what this is where an attacker has some insight about what internal packages you might be using or what you might be naming those, and figured out some ways of publishing those packages onto the public indexes and getting you to install his code. And he won tens of thousands of dollars from various orgs, Microsoft, Apple, Yelp, Tesla, through this bug bounty. One thing to note, everything that I'm talking about here applies to pretty much any language. Most package managers have some variant of this. In that bug bounty, he was able to target these three. This is Ruby gems, the NPM index, and PyPI. But we're going to focus on Python for today. But these principles apply to pretty much anything, and you want to know your tools and know what people in your infrastructure are doing. So for those of you that aren't familiar, the way this works is you'll have a package manager in Python. The default one that comes pre-installed with Python is pip. And the way you use it is you just say pip install and then whatever package name. So anyone can publish any package on the internet. It's a public index, it's global. All you need is an email address to sign up and publish packages into that index. And beyond that, with Python specifically, but this is also true of many other languages, part of the installation process runs third-party code. The developer can have additional setup stuff. This is a very simple example setup.py file. When you're installing a package, this script will run on your system where you're installing it. And if I'm a developer of a package, I can put anything I want in here. In the context of an attack, this is a very easy entry point to have code that will execute. So in this example, we're just grabbing the README from the source code and making that part of the arguments for the setup process. But you could ping out to third-party URLs, do whatever, grab keys, install malware, do anything. It's Python. So the next thing to know about with using pip is a common practice, and this is basically the default way you'll see stuff documented, is to use a requirements.txt file. So you'll say pip install -r for requirements and requirements.txt, and that's going to just have a list of all the packages that are included in there. You can have optional version numbers, and there's a couple different formats of this, but it's going to list all the dependencies. It kind of works as a manifest for getting up and running. So how big of a deal is this? Like I was kind of alluding to, back in 2017, the Pydo squatting project, they put up a bunch of standard packages and demonstrated that this is something that is happening and is real. Well, the response from PyPI at the time was to remove all their packages. It wasn't in alignment with their mission of putting up a research kind of a project to understand how bad of a problem this could be, and they removed all the packages. I think since then they've blocked those, so you can no longer do that. But at the time, the response was, take these down, they don't belong here. And what that brings up is your values or your interests may not fully align with the package index that you're interfacing with. The objective of the package index for Python is making everything kind of free and open for anyone to participate, and they're going to promote open source sharing of your code. So from a security perspective, that has some implications. Whether you agree with it or not, if you're using Python, you're probably exposed to this. Real quick, we'll see if I can get this to come up on the right page. This is an example. They run a lot of their support stuff through GitHub, so this is an issue that was reported March of this year. And this is kind of how this works with PyPI. Someone will report something that looks a little bit shady. So in this case, there's this user who has published some 3,591 packages that are empty. Looks like something shady's going on. And they'll reply, they'll look at it, they'll kick the user off, pull down their packages. That's kind of the process. So someone sees it, they report it, and then they evaluate if that's against their terms of service, and they'll remove it. So some things to keep in mind with all this. The entry point of this is probably your developers in your organization. So think of this in the context of that, but there's also build environments and production environments that you may be running these same commands in. It's going to run that setup py file like we discussed. That's third-party code on your machine. If you get a package you didn't intend, which is what we're talking about here, someone puts up something that you didn't want, and you grabbed it, that code will run. You've now got remote code execution on whatever context you just installed that in. Developers tend to have a lot of privileged access in a lot of environments. They may be on privileged networks. They may have SSH keys. They may have other environment variables or credentials or tokens that are readily available in their user's context because they're a developer and they use them. So keep that in mind with what you could grab. A Python file that goes to your SSH folder and exfiltrates that on install might be bad for you. And hopefully this doesn't need to be said here. I do occasionally have to say this when I'm working with different audiences, but if you're running a package manager with root privileges, stop doing that. You're going to wreck your whole system. So in the context of how you can get the wrong package, there's the obvious one with the just type in the wrong name. Somebody puts something up there that looks like a legitimate package, but isn't what you wanted. Like, say, beautiful soup is something used for parsing web pages a lot. Maybe someone published beautiful soup 4, and you see that, and you think that's the right thing, and it's not exactly coming from the source you think it is. There's those kinds of attacks, but a little more nuanced one is when you're using a private index. So does anyone here use private indexes or know if their org is using a private index with packages? So I'll give the short version. Is basically in Python, you can specify when you're using pip to use a private index with the URL. And I'm trying to pull up that link, but it keeps jumping ahead. So you add this extra index URL option when you're doing your pip commands or to a configuration for pip, and it will use your own index. Well, the resolution order of this with pip is it's actually going to look on the public index first. So the way that you could end up exposing yourself to this kind of attack is you think you're using a private index, someone publishes a package with the same name. On the public index, the resolution order is public index first, then the extra index is second. And it's a little bit implied with the name, but it's easy to mess up and not understand that. Okay, so this is a fixed version of the requirements.txt file. So rather than just putting your packages in there by name alone, if you're getting them from any other source, pip supports a fully qualified name. You can actually include the entire source of where that came from. So these are private repositories. This would kind of be an example of that. Or maybe they're public, but they're coming from a different source rather than the public index. You should document that in your artifacts that you leave for developers, that you leave for build environments, for your production installs. If you're not doing that and someone publishes, say in this example, this vendor product pub/sub, if someone published that with a matching version that you are asking for, you will get their code. Now, in this scenario, something generic, maybe a drive-by thing they're not going to know how to attack you. But if we think about this in the context this is going to be used, you're the target. They're trying to figure out what your internal package names are. And it's going to be a very targeted attack, most likely, if you fall victim to something like this. So simply documenting the fully qualified package with as much information as you can. So I've got version numbers on one of these. That will help prevent falling victim to something like this. One other thing to think of when you're thinking about an internal attack, you could have former employees, internal actors that might know details, very detailed details about what you're doing. And if you adopt this kind of a process, it kind of helps both some random person and an internal actor from doing something. So when you're doing the pip install, there's this complicated format here. I've kind of broken it out with some of the options that you can do. A lot of these things will depend on where you're getting it from. This one's for GitHub specifically. It tends to be pretty popular. And if it works there, it works with many of the other source code repositories. You can leave off everything after the hash there where it says egg. And it'll work if you include that. When you're trying to install, if it doesn't find a matching candidate, it'll abort the install. When you move on from the developer machine into your deployments, you may have needs of having, like, say you have a private repository, but your build environment's on GitHub. So how do you use this pattern with that extra security that you need? The preferred way with GitHub and Bitbucket, and I think GitLab also supports this, is a thing called deploy keys. These are read-only SSH keys that are specific to a single repository. So if you're including the source code already in there, it shouldn't really increase the scope of what you're exposing there, and it simplifies a lot of the permission issues. So using deploy keys as part of your deployments or on your production deployments it's very compatible with this pattern. There are other patterns you can do, but this pattern seems to check all the boxes that I considered with going from developer testing into production. There are some caveats with that. GitHub, for example, you can't use the same key for multiple repositories. So you have to generate a new key with each new project. There's a little bit of upfront overhead and some trainings. So there's nothing really enforcing this. You just have to be disciplined about it or have an audit process. Talking about other options, there are other package managers within the Python ecosystem. So pipenv is one that's popular, and it's got one very nice thing that is lock files. A lot of languages support this. Pip does not currently. It's on their roadmap, but it's not there yet. What a lock file is it's going to, as it downloads and installs things, it's going to take a hash of the file that everything that you get and generate a hash for that and make sure that anyone else that installs your project, they'll look at that lock file and it'll ensure you get the exact same thing. The other thing is their manifest file is a lot more detailed than a requirements.txt file. So when you're putting that together, you can declare a lot more of your intention of where you wanted to get it from and what version you wanted to get. So there's an example of the lock file there, just a bunch of hashes, pin versions, pin dependencies, so that nothing is different. There's some pretty big considerations, though, with changing a package manager. It's high impact. There's a reason pip is used everywhere, because it's pretty straightforward and easy. The workflows are literally what I showed you in those earlier slides, pip install -r. When you get into some of the other package managers, there is a learning curve, and you got to get all your developers, and potentially it may have consequences for your deployments. Like, for example, if I'm using virtual environments with pipenv, I'm using pipenv virtual environments to do everything. Well, the production system may or may not like to do that. It might be a different person deciding whether we should be doing that. And if they are managing Python through the operating system, they might not know that you set this up to run as a virtual environment, and you might not be getting updates to your virtual environment that's running your production stuff. So there's definitely some considerations and things that you have to look at throughout the life cycle of some of these other options. I think they're generally better from a security perspective, but there are trade-offs, and it's slanted towards the developer for where the improvements are. Another thing to note, there's some things that don't work. Like, for example, if you're using passphrases on your SSH keys or having your developers do that, pipenv has a little bit of trouble with that. You can work around that using like your SSH agent, adding the key to the environment when you want to use it, but it might cause some friction there. The other one I mentioned there is the token one. GitHub has API tokens that you can use as well. I wouldn't generally recommend using that because they're not easily scoped. Unless you're using like a utility account that only has access to what you want. Those tokens, you can say, allow me to do these things, but you can't say only on this repository. So they're global. And a lot of developers are using their personal accounts within your org, and they're just invited into your org. So there might be a lot of leakage and crossover with tokens, but pipenv doesn't even work with them. So that's kind of option one, is using a different package manager, right? You can also publish placeholder packages like the Pydo squatting team did, where they put up all the standard library ones and the ones that they thought people might type in thinking it was that project. It does effectively stop this issue. If you're able to publish a placeholder thing that doesn't do anything you wouldn't want, if it got installed, you're protected with that name. There's no other changes necessary, really, because it's all done by a unique name. You got the name that's documented. No one can put that up there. You own it. The problems, though, are you may be leaking information you don't want to. Maybe it reveals some technology or some naming scheme for other packages or in other languages, or like there's considerations with just publishing them on the public index, even if they're just placeholders. And beyond that, they might not want you doing that. In fact, they don't really want name squatting. They call it name squatting if you just put up empty packages. They'll get removed if you're doing that, and someone finds it. So definitely some things to think about, but it's an option, and it might be a good stopgap. If you're currently using internal packages and you know it's going to take some time, it might be something worth considering to put up. Just publish the package. The other thing you can do is you can just install them locally. Like you can just clone the project and install it with pip. I'm not sure if you can read that very well, but basically you just clone the project and pip install it with a path. And then that will install the package that way. And then that way you're in full control of the system. Now the downside of this one is there's really actually a value of having that manifest file and using that throughout your installation process. What tends to happen is they drift. If you're not actually using something like a requirements.txt file or a pipenv file, they tend to get out of sync with what the actual dependencies are. This is circumventing that file, and anytime it's not being validated, they're going to get out of sync. This is an automatic way to document things, and it's actually a huge benefit. So wouldn't necessarily recommend it, but if you don't have any other options, this works great. Okay, so moving back to I don't remember where I had it. This right here. So the setup py file. This is kind of why this is maybe a bigger deal than you think. This will generate a valid package, and you can install this. So let's think for a little bit about what might be included in here. If I'm struggling a little bit, sorry. If we actually, I'm just going to pause for a second. Are there any questions? It depends how you make it the primary source. So he's asking if you set up your own index and run it on your network and set that as the primary source. So the easiest way to do that, or the common way you'll see, is with that extra index. And that is not going to solve this problem. This is what, like, in that dependency confusion write-up, this is what these orgs were doing. Like Apple and Microsoft and a bunch of them, they were running their own internal index and having all the developers set that as their index. And then because of the resolution order where the public index is first, they were still able to get the just validate it is what I'm trying to say. Is like there's some massive orgs with massive teams that got that wrong, made assumptions that by having a private index that they weren't being exposed to this, right? So you got to really make sure you validated and vetted your implementation of that, because it seems to me that it's easy to get wrong. So just make sure you validate and vet that. Are there any other questions? Yeah, so the question is, changing culture is kind of hard. How do you, things can be missed or overlooked. How do you make sure it's changing, right? You're actually affecting change? Yeah, it's hard. It really is. Like the context that I'm in right now is Utah State University. There's lots of different teams and lots of different levels of expertise and engagement and involvement around this stuff. I'm on the developer side, but I don't control what's on the other side. So me saying, hey, we're all going to switch to this new package manager that has lock files, that has better manifests, that's a decision that's not my decision to make for my org. So there's that aspect, but then even within the dynamics of my own team, it's like, yeah, how do I affect change? And the way that I've done it is mostly through being a champion for the change that you want. So you show how you can do this without creating a whole bunch of extra effort and overhead. And this is one with some training, a little bit of training. Mostly if you know this is a potential and you know that there's a way to resolve it, like with fully qualifying the name, you can work around 90% of the issues just with that knowledge. And being able to adopt that yourself on your project, and if you're doing any kind of code review, or if you have the opportunity to give some feedback to any of the code in your org, just letting them know some of these details and educating them on what could go wrong with it. Like remote code execution is something most people understand, or this could expose us to malware. Some of those phrases of saying like, and here's the better way, and showing like a fully qualified name it does work. People listen. They're not trying to not be secure. There's just a lot of other responsibilities that you're competing against. So I think being a champion for it and showing that it's not a lot of overhead, and then just helping, like just watching things and helping improve. The next step is having some kind of an actual process. We haven't taken that step yet around this in our org. So it's mostly just our own internal oversight that we're doing. Yeah. So we're kind of talking about some of the tangent benefits of speed and performance. You can use arguments like that to help advocate for change, because if you're giving them something, they're going to be a lot more interested in what you're talking about. And I'm not sure I caught all of it, but does that summarize kind of? But yeah, to your point with the new developers, a lot of times they're just going to do this. And if you've only documented that in your requirements file, and they're just supposed to look in the README to see that PyMyOrg's API, you have to go install yourself first, and someone publishes that, this happens for sure. So like fixing this layer of this, especially around new developers, because they don't know the sequence, they don't know all the details, they don't know the history. And even if it's in the README, they might have glanced over that and just done a pip install. So the more details you can get into any artifacts and make it part of the process instead of just relying on a README or internal knowledge is a very effective way to affect change, because it's the way they're going to do it. This is the default way you interface with Python packages.
So when they publish the packages, nobody audits those? Like there's no person who's set to audit them at all?
It's a reactive process. So you publish a package today, it's live as soon as you publish it. It just requires an email address. And as of a few months ago, it wasn't even like verifying that. I could literally say I'm someone at some org.
Like if you really wanted to do it in a malicious way, like you were saying, I think you used OpenSoup, was that right for your?
Beautiful Soup, yeah.
Yeah, Beautiful Soup. So you post one that says Beautiful Soup version 4, right? And on your requirements file inside that, you would put like the actual Beautiful Soup, so it looks like it's functioning properly, and then you put whatever else you wanted to in it.
Yes, exactly. So a lot of the techniques with malware embedded in any package with any language is they will clone the real one and then hide their payload in there. So you don't know that you got the wrong one.
That requirements file is in there and will install automatically all the dependencies that are in that file?
Yes. And if you got the wrong one in your requirements file, everybody's going to get the wrong one. So, but that's true of anything. And it's the same with like domain names on a web page or something. Like if you send them to a malicious source, you're going to get that. One thing that keyed on for me, a lot of other package indexes allow for namespaces. Like you could go and register, like I work for Utah State University, we could go register Utah State. And then that is like a protected namespace that's like a prefix to any packages, and no one else can start with that. PyPI kind of has it, but it's not really accessible to... Yeah, it's kind of like a wildcard domain. Like you get a prefix that is reserved for that account, and only that account can publish with that prefix. PyPI kind of has it, but it's for popular packages, and it's up to the maintainer's discretion. So it's not like something you can just register. Whereas with like, say, the NPM registry, they moved everything to that, and you have to put everything in a namespace now. And that protects with a lot of stuff, because then all of your audit of your requirements file is just, okay, do all of our internal packages follow, like, are they published this way? And if you do that, you don't actually have to publish them because they wouldn't be exposed in another language. If you don't meet the criteria of being allowed to do that for PyPI, which is basically popularity, they won't give it to you. Any other? Yeah, so he's asking data science and using a Conda environment. So it's going to have its own version of this, but it is a little bit different because I think there's some other layers in there. I'm not very familiar with Conda, but I do believe there's an additional layer in there that may make it better or may make it worse, and you'd have to understand what some of those trade-offs are. A lot of the other package manager clients still interface with PyPI, so you're just talking about a different interface and a different artifacts. Whereas with Conda, I think there's an additional layer that you would want to assess. But I'm not very experienced with that. We got any other questions? All right. We'll end there.